Lesson 9.3 is solving quadratic equations by graphing. So we have solved quadratic equations before. We did it actually in chapter 8, and you solved those equations by factoring, and now we're going to solve them by graphing. So your first vocabulary word is a quadratic equation is an equation that can be written in the standard form. Ax squared plus bx plus c equals 0, where a is not equal to 0. Because if a were to equal 0, then the x squared term would not exist, and that would make it a linear function. And we're looking at quadratics. So again, you've used factoring to solve the quadratic equation. You can also use graphing to solve it. Notice that the solutions of the equation ax squared plus bx equals 0 are the x-intercepts of the graph. I've spoken to you about that before we actually looked at what the graph is. I said where the parabola crosses the x-axis, those are the solutions. It's what is x when y equals 0. And so here's an example. They give you x squared minus 6x plus 5. If you were to factor that, you'd get x minus 6 times x minus 5, so those solutions are 1 and 5. Well, when you graph this out, you're also going to get the parabola to cross at the points where x is 1 and x is 5. So those are the solutions. We're going to go ahead and do a couple of these by ourselves with graphing. So the first thing we want to do is graph this function. It does have to be set equal to 0, and this one actually is. Remember before, we looked at a. In this case, a is negative 1, b is negative 6, and c in this case is 0. So that's okay. 0 is a legitimate number. The first thing I want to do is find my axis of symmetry. Recall that that's the opposite of b over 2a. So in this case, the opposite of 6 is negative 6 is 6 over 2 times negative 1. That gives me a negative 3. And then I want to find the vertex. The vertex is negative 3. And then I have to put the negative 3 up into each of these x values to find the y value. So I'm going to go ahead and do that. And when I did that, I got a 9. Don't forget, this means take the opposite. So you're going to end up putting the negative 3 in here. Negative 3 squared is 9, but then you have to make this a negative 9. So now I'm going to go ahead and sketch my axis of symmetry. Remember, it is the invisible line, but to show that it's invisible, we're just going to go ahead and, there we go, put it in with a dashed line. And I'm going to put my vertex on here. It's negative 3, positive 9. So there's my vertex. I know that this is going to open down because it has a negative a value, and now I'm going to make a table. I do know another point on here is 0. So at 0, it is 0 because my y-intercept is 0. So when x is 0, y is 0. And then really, if I want to look at this, I'm only, let's see, 1.5. So right here, I don't really technically have to make a table as long as I'm the same distance away from, whoops, except I didn't. There we go. I need to be the same distance away from the axis of symmetry. And this one's kind of nice because it did go right through the two x-intercepts when I did this. So my solution here is x equals negative 6 and x equals positive 4. You have to be careful because notice that this, so you have to be careful, and I wasn't careful. You have to be careful because here's the x-axis, so x is 0. I was looking at that as a 2 because I didn't see the negative 2. So here's your xy axis, and this is going in 2, so x is 0 and x is negative 6. Let's go ahead and try this next one. So again, I have a is 1 here, b is negative 6, and this time c is 9. Whoops. 9. So my axis of symmetry is the opposite of b, so 6 over 2 times 1. So my axis of symmetry is 3. Let me scooch this over a little bit. And now my vertex is 3 comma. I'm going to go ahead and put 3 in here. When I put 3 in here, that gives me 9 minus 18 plus 9, well, that gives me a 0. So 3, 0 is actually, my vertex in this case. This one's going to open up, so I want to go ahead and make a table. I also know that 9 is my y-intercept. So right here, so technically, I guess I don't have to make a table on this one either because of the way that the graph is written. If I go 1.5 over, and by 1.5 I mean 1.5 spaces on this graph, then this is good. So I've got my 3 points. And in this case, there's only one solution, and that solution is x equals 3. So this is an example of where there's only one solution. All right, which leads us into this next portion. For a quadratic equation, you can have two solutions if the graph of its related function has two x-intercepts. So it could look something like this. It could be flipped over, a reflection. Your quadratic is going to have one solution if the graph of its related function has one x-intercept, and that was like the one that we just graphed. Or your quadratic equation can have, no real solution if the graph of its related function has no x-intercept. So it is possible that there are no solutions with the graph. Finding the zeros is basically saying solve the equation. It's just another way of putting it. It says because a 0 is an x-intercept, you can use the function's graph to find the zeros. So again, here's another one that we're going to go ahead and graph. First thing we need to do is, let me label A, B, and C. And now the opposite of B is 5 over 2 times -1. So this gives me -5 halves. So that's -2 1/2, and that is my axis of symmetry. I'm going to scooch it back just a little bit. That's about as close as I'm going to get it on here. Okay, now I need to go ahead and find my vertex. So I know it's -2 1/2, and I need to plug that in here. So I'll go the opposite of -2 1/2 squared minus 5 times 2 1/2 minus 10. Notice up here I squeaked in the little negative. That's a -2 1/2, and my answer is -3.75. So -2 1/2, -3.75. So there's 2, 4, so maybe right around in here, we'll say. Okay, I do know that this graph is going to open down. So if this opens down, I can tell already I'm not going to have any solutions, because the only way I'm going to get a solution is if this were to swing back up. But I am going to go ahead and make a table. I do know that my y-intercept is at -10, but I'm going to come up with another point over here, so I'm just going to go ahead and put in -4. So if I put a -4 in here, that's the opposite of -4 squared minus 5 times -4 minus 10, and we'll see if that gets us anywhere on the scale that they've given us. And that does give me a -6. So at -4, it's -6. This gives me a pretty good bend. I'm going to check real quick and see what it gives me at a -6. At -6, it gave me a -16, which is off the chart. So I'm just going to try to bend it down. Oops, like this. And here's what it looks like. And I do know, again, that I have no solution for this one. So with the graphs that I've shown you today, back here you have two solutions, one solution, and now you have one that's no solution. All right. Of course, we're going to have the story problems. This is an athlete throws a shot put with an initial vertical velocity 40 feet per second is shown. Write an equation that models the height in feet of the shot put as a function of the time in seconds after it's thrown. So we know the height is negative 16t squared plus the initial velocity is 40 feet per second, so 40t, plus they're showing us that she releases it when she's 6.5 feet, when the ball is 6.5 feet off the ground. So there's the equation. Now they want to know how long was the shot put in the air. So in other words, when did it hit the ground? What we're going to do with this is we're going to actually use Desmos to graph this, because the values we're going to have to actually estimate because this doesn't have integer value answers. So I want you to go ahead and you can just pay attention to this because I'm going to take you to Desmos right now. Okay, so here we are at Desmos, and I have put in the equation y equals negative 16x squared plus 40x plus, oh, I don't know why I put in 605, so let me pause. Much better. How about 6.5? So here is what I have, and I set up my table. I just went into the table. I know you can scroll back and forth to get it, but what I'm looking for are the zeros. So if you come here and you just click, it looks like the zero is approximately negative 0.15, but that doesn't really help me out at all because I can't have negative time. And the other one is approximately 2.7 seconds. So this is one way that you can find it. I don't want you doing this for all of them, but with the story problems, if it doesn't have a nice integer for the C value or the A or the B, go ahead and feel free to use your Desmos graphing calculator to get this. So my answer here is that the shot put is in the air for about 2.7 seconds. So T is about 2.7 seconds. And I apologize that this video has had a few bumps and scrapes. Okay, last thing. Relating solutions. So all of these, you have to understand that this terminology means the same thing. When you have the solutions of a quadratic, when you graph it, again, it's where it crosses the x-axis. So my solutions here are 2 and 6. That's the same as the x-intercepts. The x-intercepts are 2 and 6. Those are the solutions, which are the same, so they're synonymous with the zeros of the function. So if they ask you for the solution, the x-intercept, or the zeros of a quadratic, they are all meaning the same thing. All right, your assignment is going to end up being another worksheet. So if you want to, you can print it off. It's going to be worksheet B. Honestly, I don't know yet if I'm going to assign the odds or the evens or all of them. So it's really up to you on whether you want to start. There's no problem with you doing extra work, but I know sometimes you don't really want to do that. So have a good week.